Right. When you look to divide, there's really only one additional step that you have to do compared to multiplying. Okay? And that is before we even begin. So you can call it step 0 if you want, because the steps just like multiplying will be exactly the same. But the only step that you have to do is you convert from a divide into a multiply. Okay? Division is multiplying by the what? Reciprocal. So all you have to do here is convert to a multiplication by inverting your fraction. Okay, so in this same step, again, I'll call this 1a and 1b because it's all, you can do this all in one step. So if you convert this to multiplication by inverting your fraction, and then at the same time you're going to factor everything completely. Okay, so my numerator of my first fraction doesn't change. It's a monomial factor. My denominator is a perfect square trinomial. You could test it if you want. It's a base x squared, a base 6 squared. If you take those two bases, multiply them together and double it, you get this middle term, so it is a binomial square. The terms of the binomial are x and 6, and the sign is whatever the sign of the middle term is, plus. So here's the completely factored form of my first fraction. My second fraction, I'm going to invert and multiply. So my 12x, my monomial factor, moves down to the denominator. Again, I don't have to change anything about it. My binomial factor gets moved to the numerator, and I can remove a common factor of x, leaving x plus 6. And then you perform the exact same steps that we did in multiplying. We're going to cancel any common factors. Okay, so here as we go through, between 9 and 12, we have a common factor of 3. 3 goes into 9 3 times, into 12 4 times. We have the x's. I'm just going to cancel these two x factors here. And we have an x plus 6, so I can cancel one of the x plus 6's from the denominator. So when I write the remaining factors, I have 3x squared across the numerator. In the denominator, I have a 4 and an x plus 6. Okay. My final step is to identify any domain restrictions. And now notice I put a star here. This is the place, again, where the most trouble comes in this. Okay? So there's two things that are different about dividing than multiplying. The first is you have to perform this kind of initial step, invert and multiply. But the second is when you identify domain restrictions, you have to consider domain restrictions in the second fraction's original denominator. And so what that really means is when we go to this step right here of identifying domain restrictions, I'm going to kind of block it in orange here, you have to look at every single factor in this entire fraction, both the numerator and denominator. Okay? The numerator, because this was originally the denominator. So you see that x, when you're looking for domain restrictions here, oops. Okay, you see from this one right here, x was originally would have given you division by 0 of this second fraction. So you know that x can't be 0, you know x can't be negative 6, and you know here x can't be 0. Okay, so look at every single domain restriction in that entire fraction. Okay? You can't have any zeros anywhere in the numerator or denominator of the second fraction. So when we look to test this, is the domain restriction that x can't be negative 6 apparent in our simplified form? Yeah, right here we see x can't be negative 6. So we don't need to include that. What about x can't equal 0? Is that apparent in our simplified form? No. So you need to include that as the domain restriction. Okay? And that would be the only one that you'd have to identify based on the simplification of that. Make sure that you do that step. Most students will forget to check the factors up on the top here when they invert and multiply. Okay, but you have to do the check. Check every single factor in this entire second fraction. All right, try this one on your own. All right, let's talk through the steps here. So step one, we're going to invert and multiply and factor everything completely. So in this first fraction's numerator, I can remove a common factor of 5y, leaving y plus 4. In the denominator, I can remove a common factor of y squared. That leaves a y minus 2. I change this to a multiplication, so that y squared minus 16, I'm going to factor and put those factors in the denominator. So it's the difference of two squares. This is y squared and 4 squared, so I'm going to take the sum and difference of those two terms. Okay, and then my denominator of my original fraction gets moved to the numerator. So I'm going to find the binomial factors here. The two factors of negative 12, whose sum is negative 1, negative 4, and plus 3. Right, move to the second step, which is to cancel any common factors. So here as I go through, my y cancels with this y plus 4's cancel, y minus 4's cancel, and I'm left with the y plus 3. Nothing else cancels. So when I multiply across the top, I get 5 times y plus 3. In the denominator, I have my y, and I have my y minus 2. Okay, so there's my simplified fraction. All I need to do is identify any domain restrictions that are not apparent in the simplified form. Okay, so I need to look at any factors that were canceled from the denominator, as well as any factors that remain in this entire fraction. So here's a factor that was canceled from the denominator. So y can't equal 0, y can't equal negative 4, y can't equal 4, y can't equal 4, and y can't equal negative 3. Even though it didn't get canceled, that's still a domain restriction you have to account for, because that would have given you division by 0 of this original fraction. Okay, so let's go in and see which of these is not apparent in the simplified form. Y can't equal 0. Can you tell that from the simplified form? Yeah, so we leave that. Y can't equal negative 4. Is that apparent from the simplified form? No, so I'm going to include that, y not equal to negative 4. Okay, and I'll go in order here. Y can't equal negative 3. Is that shown in the simplified form? No, so I have to include that restriction. And then y can't equal 4. Is that shown in this simplified form? No. So those are all three going to be domain restrictions that I have to include in addition to.
How come you didn't include the y cannot equal 2?
Because that's apparent in the simplified form as well. If you wanted to test it, you could and see that that's apparent and remove it. If that helps, you can. What I'm doing is I'm going through any factors that got canceled from my denominator of the first fraction and then every factor of the second.